This video covers section 1.2, graphs of equations. In this video, we look at sketching the graph of an equation by point plotting. Often in mathematics, we are interested in the relationship between two quantities. And one way to do that, of course, in mathematics, is to write an equation in two variables. Most often, we're going to use an ordered pair with x and y. As you move through mathematics, particularly linear algebra, when you're doing 3 or 4 or 5 variables, we then switch to things like x1, x2, x3, and so on. But for the purposes of precalculus, we're going to stick with x, y, and eventually z. So again, if we're looking for a solution to this equation, we are going to look for an ordered pair, an x and a y value, that makes the equation result in a true statement. So we have a practice question here to do together. It says determine whether the points 2, 8 or 4, -2 lie on the graph of y equals 3x minus 14. So y equals 3x minus 14 is an equation in two variables because it uses the variable x and y. Now we're going to determine which one of these points, if any, result in a true statement. And if the equation results in a true statement, that means the point is on the line. So let's take a look first at 2, 8. Remember, ordered pairs are in x, y format. So I'm going to replace y with 8, and I'm going to replace x with 2, and then I'm simply going to say, is that true? So on the left, no math to do. On the right, 3 times 2 is 6. 6 minus 14 results in -8, and of course 8 does not equal -8. So therefore the point 2, 8 is not on the graph of the line. Let's look at 4, -2. Y is -2, x is 4, and we're saying, is this true? -2 equals 12 minus 14, -2 equals -2. That is true. So when we graph this, we should see that 4, -2 is in fact on the graph of the equation. And just quickly, I showed you a picture where 2, 8 obviously not on the line, and 4, 2 is on the line. Obviously, a large part of our study in Algebra 1 and 2, or intermediate and college algebra, has to do with how to graph lines, whether they're linear, quadratic, cubic, and so forth. But what you can always default back to is graphing by point plotting. So again, hopefully we can all see, hey, this is an equation that's in slope-intercept form, and I know a much easier way to graph that. But if you don't, or if you ever get stuck, remember that you can always just go old school and make yourself an XY table. Now you can make your table as involved as you want it to. I'm just going to take -2, -1, 0, 1, 2. And again, all I'm going to do is replace x with the x value that I've made up and determine y. Now you can do as much mental math as you want, but remember, essentially what I'm doing is I'm saying y equals 2 times -2 minus 3. So it would be -4 minus 3 or -7. Now, hopefully we're past the point where we have to write it out, so let's just do it mentally. 2 times -1 is -2 minus 3. 2 times 0 is 0 minus 3. 2 times 1 is 2 minus 3. 2 times 2 is 4 minus 3. So I can then plot the points -2, -7, -1, -5, again x, y, 0, -3, 1, -1, and 2, 1, and then connect the dots. And keep in mind that though I have found some discrete points, meaning I have found 5 points, the actual solution or the actual graph is those 5 points and all of the points in between and all of the points that I haven't found. So I'm going to then use an arrow on each end to indicate that this is going to go on forever and ever following that pattern. Let's do the same for y equals -x squared plus 5. Again, make up some values. Always a good idea to use some negatives, some positives, and 0 just to make sure we know exactly how the graph's going to work. Again, hopefully we can see that this is going to be a quadratic that's upside down because it's got the negative in front of the quadratic term. But again, we can always look back and just do this the old school way. So y equals -2 squared plus 5. Keep in mind, when I square negative, it becomes positive. So that's, oh, sorry, I forgot the negative out front. Y equals -2 squared plus 5. So this is going to give me -2 squared is 4. 4 plus 5 is 1. So -2 comma 1. -1, do the same thing. -1 squared is 1, but I make it negative. So -1 plus 5 is 4. 0 plus 5. And then again, 1 plus 5. That's going to give me the exact same thing I had with -1. And then 2 squared is 4, but I make it negative. Plus 5 is 1. So I've got -2, 1, -1, 4, 0, 5, 1, 4, and 2, 1. And again, arrows on each end. This short video gives us an introduction to finding the intercepts of a graph. However, if you're not familiar with factoring, you will want to look at some of the factoring videos that are linked in the description. Another important aspect of graphs that we need to understand is how to find the intercept. The x-intercept or intercepts and y-intercept or intercepts. So the easiest thing to do here is to replace x with 0 and find y, or y with 0 and find x. Simple concept, the execution can be more difficult. So for instance, if I am finding the intercepts for my first question, obviously this is a line. Hopefully you can see that it's a line because x is to the first power. Nothing is, in the denominator. You get the idea. This should be a nice linear equation. So how do I find the intercepts? Well, I replace y with 0 and solve for x. So add 4 to each side, divide by 2 on each side. So x is 2. Remember, that means when x is 2, y is 0. So that's the point. And then same thing, I'm going to now replace x with 0, which of course is generally the easier one. So y equals 2 times 0, or 0 minus 4. So y is -4. That of course gives me the point 0 for x, -4 for y. So those are the two intercepts that will be on the line. Now for the second one, I threw one in here that requires you to know some factoring. So hopefully you are very familiar with factoring. If not, I am going to link some factoring videos in the description of this video so that you can go back and remember how to factor. So in this one, I'm actually going to factor by grouping. That's one of our strategies for when I have 4 terms, and it doesn't always work. But in this one, I'm going to say, if I were trying to factor this, and again, this is when I'm setting y equal to 0. So I'll do the x equals 0 in a moment. That's the easy one. Here, I'm going to say, what could I take out of both 3x cubed and 2x squared? And I can take an x squared out of that. So what's left over? If I divide this by x squared, I get 3x. Divide this by x squared, I get -2. Then I look at 6x and 4 and say, what could I take out of both of those? And I could take out a 2, but I'm actually going to take out a -2 because this term is negative. And that leaves me with +3x and -2. And this will work by factoring by grouping because these two binomials are the same. So again, how do I factor by grouping? I take the 2, I'm essentially taking the common factor of 3x minus 2 out of both terms, which leaves me with x squared minus 2, and then 3x minus 2. Again, equals 0. So why is that important? Because again, I'm now trying to solve. So I'm going to say, by the 0 product property, 0 equals x squared minus 2, 2 equals x squared. So radical 2 plus or minus radical 2 is equal to x. So that's going to be both of those points, comma 0. And then of course 3x minus 2 equals 0 means 3x is equal to positive 2. Divide by 3, I get 2/3. So those are again x-intercepts, so those values come as 0. And then the y-intercept, of course, is the easier one of the two. Y is equal to, if I plugged in a 0 here, I would get 0. If I plugged in a 0 here, I would get 0. If I plugged in a 0 here, I would get 0 plus 4. So y is equal to 4, which is, of course, 0, 4. Now, if we graph this, we can certainly see that the point 0, 4 that we just found is right here. All of those points that we found for the x's, this is negative radical 2. This is 2/3, and this is positive radical 2. And if I move to my first example, 2, 0 is this point, and 0, -4 is this point. So we can see that we have verified all of the intercepts that we found mathematically. In this video, we look at graph symmetry. Another property of graphs that's helpful to know is a test for symmetry. So it's helpful to determine if the graph is symmetric to the x-axis, the y-axis, or the origin. And the tests are found by, for the x-axis, we replace y with negative y. So if we replace y with negative y and the resulting equation is unchanged, then we know that the graph is symmetric to the x-axis. Same thing with the y-axis. If we replace x with negative x and the equation is unchanged, it's then symmetric to the y-axis. If we can replace x and y with negative x, negative y, and the equation is unchanged, then we know for sure that it's symmetric to the origin. Now the origin's the tricky one, because obviously with the x-axis, we're saying whatever happens here is going to be reflected across the x. And with the y-axis, we're saying whatever happens, say, on this side will be reflected on the other side. But with the origin, we're essentially saying whatever happens here is going to be rotated around to the opposite side. So it's rotated 180 degrees around the origin. So let's take a look at the math behind this, and then we'll take a look at the the graph of the equation to see if we did the math correctly. So I'm going to start by replacing y with negative y. So here's my equation, and I'm going to say negative y equals 1/4 x cubed, and then simplifying that gives me y equals negative 1/4 x cubed. So does this equation match the original? No. So that means this is not symmetric to the x-axis. Now let's do x with negative x. If I replace x with negative x, I get y equals 1/4 negative x cubed. Now, if I take negative x cubed, I get negative x times negative x times negative x. So two of those negatives make a positive. That's essentially going to give me negative 1/4 x cubed. Is that the same as the original? No, it is not. So this graph is not going to be symmetric to the y-axis. So let's look at the last one, the origin. I'm going to replace both x with negative x and y with negative y. So negative y is equal to 1/4 negative x cubed. If I take the negative x to the third power, that gives me negative 1/4 x cubed. And now I can see I have a negative on each side. Dividing by a negative gives me positive y equals 1/4 x cubed. Does that match the original? Yes, it does. So when I graph this, it should be the case that the equation is symmetric to the origin. So looking at this, I can see whatever happened here then got rotated around 180 degrees and matches what's there. So we did the math correctly. I can see that it's not symmetric to the x because that would be here. It's not symmetric to the y because that would give me a line here. So we get the idea that that's how we check for symmetry. Let's take a look now at how to use symmetry to help us in graphing a line. We're going to start, as we did before, by replacing x with negative x, replacing y with negative y, and replacing x and y with negative x, negative y. And again, what we're doing is looking to see if the equation remains unchanged. So I'll start with replacing x with negative x. That would give me y squared is equal to negative x plus 3. And the question is that always going to equal x plus 3? And the answer is no. If x were 0, yes, that would work out. But if x is anything else, those two values will be different, so that is a no. If I replace y with negative y, that's going to give me negative y squared. And negative y squared, as we know, is going to be a negative times a negative, which is a positive. So that's still going to give me y squared is equal to x plus 3, which is the same as where I started. So that is a yes, and that means it's symmetric with respect to the x-axis. So that's this axis, which means whatever I do on one side of that axis, I can flip it over to the other side. Lastly, let's take a look at replacing x and y with negative x, negative y. And hopefully you can see we're going to end up with something very similar to our first attempt, which would give me still a positive y squared, but a negative x squared. So that again is going to be a no. So not symmetric with respect to the y, not symmetric with respect to the origin. Now what I'm going to do is I'm going to simply create an xy table. Typically in an xy table, I would come up with the x value, and you can certainly do that. But for the sake of simplicity, I'm actually going to come up with the y value, and then I'm going to actually write down what y squared is, because that's what I'm going to use in my equation. So if I use, say, 0, 1, and 2, then y squared is 0, 1, and 4. So what I'm going to do is say y squared, which is 0, is equal to x plus 3. So that means x would have to be negative 3, obviously by subtraction. Minus 3 minus 3, negative 3 is equal to x. I'm going to do that as well for 1 is equal to x plus 3, which would give me negative 2, and 4 is equal to x plus 3, which would give me 1. So what I can do is I can now plot these points, negative 3, 0, negative 2, 1, and 1, 2, which we can see is half of a parabola. And because this is symmetric to the x-axis, I can really just flip those points to the opposite side of the x-axis and come up with the remainder of my graph. In this video, we will take a look at the standard form equation of a circle. Let's take a look at circles. Now circles, hopefully we know, are one of the conic sections. You may or may not have studied what conic sections are, but certainly you have studied parabolas, which are one of the conic sections. Circles are another. And then of course we have the hyperbolas and ellipses, which we will study later in this course. But let's take a look at the equation of a circle. So hopefully we know the circle has a center point, which we just call the center. And all of the points on the circle are equidistant, or the same distance from that center point, and that distance is called the radius. Now, we have already studied the distance formula in this course, and the distance formula says to find the distance between 2 points, we're going to take the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. And so using that distance formula, if we say the center is a point hk, and any point on the circle is the point xy, we can certainly just do some replacements to find that the distance, or radius, is the square root of x minus h quantity squared plus y minus k quantity squared. Now, we don't love dealing with square roots, so what we do is instead we take the square of each side to give us r squared is equal to x minus h quantity squared plus y minus k quantity squared. This is the standard form of the equation of a circle. So this is the form that we're going to be using moving forward. And again, keep in mind that the center, of course, is h comma k, and the radius is r. While I won't be asking you to graph any of these, I do want to talk to you about how to use that formula to write the equation, the standard form equation of a circle. So if you'll recall, we just said that x minus h quantity squared plus y minus k quantity squared is equal to r squared. So pretty straightforward for this first question. It says write the standard form equation of the circle given the center of 2, 3 and the radius of 5. So if the center is 2, 3, that's h and k. So I'm going to say this is x minus 2 quantity squared plus y minus 3 quantity squared is equal to r squared. So this is obviously r. So 5 squared, which is 25. Second one, equally as straightforward. X minus -1, which turns into x plus 1 quantity squared, plus y minus 4 quantity squared is equal to 2 squared, or 4. For the third one, almost as straightforward, but I gave you the diameter instead of the radius. So just remember, to find the radius, I'm going to take diameter divided by 2. So that means the radius here is going to be 6. So again, this would be x minus 0 quantity squared. So we're just going to write that as x squared. And then plus y minus -5, so that's y plus 5 quantity squared. Again, we took 12 divided by 2 to find 6 as the radius, but I still have to square that, so that's 36. For the last one, I gave you one that was a little bit more difficult. We have a center of 1, -2, and it passes through a point -3, 4. So we can obviously visualize that. We can plot the center, and we can plot the point -3, 4 and see what the circle looks like. But really what we're doing is we need to find r. And r is just the distance between those 2 points. So I'm going to use the distance formula with the point -3, 4 and 1, -2 to find the radius. So I can put d equals or r equals. So here I'm going to take the difference of the x's, so -3 minus 1 quantity squared plus 4 minus -2 quantity squared. And again, if you want to go straight to plus 2, that's just fine. I just want to make sure I don't lose anyone along the way. -3 minus 1 is -4, and I'm going to square it. 4 plus 2 is 6. That gives me 16 plus 36, which is radical 52. Again, do I need to worry about doing any reduction there? No, because I'm trying to find the standard equation of the circle, which is x minus 1, because that's the center, quantity squared, plus y plus 2, because it was minus -2, quantity squared, equals, this is the radius, sorry I used d, this is the radius, and I'm going to square it. So radical 52 squared, which is actually just 52. Coming up next, we're going to do a deeper dive into linear equations with 2 variables.